New for Softimage 2014 has been a significant improvement to the management of actors and their behaviors in the crowd effect system. I've got a sample city block here that is some kind of post-apocalyptic or Civil War based environment, and it's these 10 fortunate actors here who get to play their part in sort of explaining how this system works. It's really quite robust and extremely open to customization. So rather than start with this system just to show you the basics, because here I've got all the characters loaded into the system and that can take a bit of time, I'm going to start off in a blank scene, load in a couple of characters to show you how the process works, and then come back to this scene and show you how we can implement a number of different behaviors and actions for these myriad of characters. So I'm going to flip over to a fresh copy of Softimage, and of course it starts off in the ICE toolbar under the Crowd Effects subheading in the Simulation button. Under the Simulation button we have quick ways of generating crowds, some very basic crowds here where we're responsible for hooking up our own actions and converting them to animation states, or we can start with a predefined pedestrian crowd. If I open up the Explorer, I've already ran the new pedestrian crowd, and it's built me a model, and in that model I've got a bunch of hierarchies that are sort of sitting there waiting to receive the different actors that I want to bring into the system. You can do that by accessing the custom property, the Crowd Effects Pedestrian Setup. And you can see under here that we can either import our own model, get an existing model in the scene, or utilize a default pedestrian that's provided with Softimage. The other important part to this is to understand the simulation context of this crowd effect system. If we take a look at the point cloud where the entire crowd effect system is managed, let's open up an ice tree. And if we have a look at the 4 ice trees or ice branches that we need to implement here, 2 of them will look familiar to what you saw in the original crowd effects release in 2013. You know, in the modeling stack where we're initializing data, we're getting our animation sources, where we're setting all of our actor cycles. This is bringing in a particular model and loading in their relevant actions so that they can be used by crowd effects. We've got the emit initialization branch, where again nothing's really implemented here. We're emitting particles from a given emitter object, initializing collision avoidance, giving the actors thickness for penetration, giving them horizontal field of views, giving them distance to interaction limits, as well as setting things like social groups, acceleration and deceleration. And finally, we're able to set up the actor IDs that are used in our system, as well as the target speeds that they should hit. The main implementation, or the main changes, of course, have been in the overhaul of the behavior tree as well as the animation blending tree. If we take a look at the animation blending tree first, the animation blending tree is where we would define our different animations and bring them into what we call animation states, define transitions between them, and then use the behavior tree to set up the logic for how the characters should utilize those actions as states and how they should blend together based on triggers within the scene itself. You can see here that the main core of this behavior tree is, surprisingly, the behavior core, where in the simulation branch we're defining the type of simulations that we want to use, as well as the logic that's used to trigger the different animation states down in the animation state portion of the behavior core. We've got the post-simulation branch where we add basically interactive effects like sticking to ground, avoiding walls and obstacles, as well setting some basic logic here which determines the flow of these different states. So whether we use a moving state or whether we use an idling state. So let's take a look at this once we've brought a couple of actors into the system. So once again, I'm just going to go into the Crowd Effects Pedestrian Setup. Again, this would all be brought in by building a new pedestrian crowd. It would build exactly what you see here. And I'm going to import a character. We'll start off by bringing in this character with jeans. I'll import the model. And what that's going to do is it's going to set up a Crowd Effects Pedestrian Setup where we define an idle source for the character. So I've got a few sources available to me here. So I'll just go in and I'll bring in, let's say, character talking normally to somebody. And then what we want to do is load in the movement sources from slowest to fastest. We can, of course, add our own additional animation sources as well. So I'm going to go from a 33 frame walk cycle loop to a 21 frame run cycle loop. Now these are, of course, progressive animations, meaning that they're moving from the origin forward in local Z to a given distance. And it's that movement over distance that CrowdFX uses to determine the velocities of your characters. Of course, if I have a third animation source, I can use that to define, I have a version of a run where my character's turned around looking terrified at what might be chasing him. In my case, let's keep it simple. Let's just remove that third movement source. Let's get an additional actor. And as we're doing this, what's happening is it's now processing the first actor. It's adding proxy deformers, so it's determining. I'll just switch back here. So what it's doing is it's determining the different deformers that are going to be needed based on the existing deformers of the model that you've imported. So the nice thing about CrowdFX is that it can take any type of model. It can take a car, it could take a quadruped. It's really based on the deformers that are driving the system. And of course it needs a center of geometry to help define the velocity of the character. Alright, so it's brought one character into the system, and let's bring in one more. Let's import a second character. So we'll do that. Let's bring in a female character. Let's bring in Eliza. I'll bring in the green one. So we bring Eliza in and we do pretty much the same thing. We're going to define her idle source, which would be, let's have her talking on the phone. And let's have her transition from a walk cycle, 33 frames, to a run cycle, 19 frames. And from here, we'll create our pedestrian crowd. So again, it takes a few minutes to set up the pedestrian crowd. The reason I'm setting it up here, just as my first example in a blank scene, is with my large city set, it takes a little bit longer to load these things in. So when I move back to the city set, you'll at least be able to see how the process works in a timely fashion. Okay, so it's now processing the proxy deformers, it's loading the animation cycles onto the character, or into CrowdFX, and it's loading them in as animation clouds that basically define the pivots or the rotations of the various items in the rig, in each rig. So this is the crowd that's been set up for me. You can of course see my two original actors here. They're kind of grayed out. We can handle those characters pretty easily. Let's just jump right back into the CrowdFX setup. Sorry, not the CrowdFX setup. Let's actually just go in and look at the actor proxies, inspect them. And we can now view each actor that we have in our CrowdFX system. So I'll take, let's say, Eric, for example. Let's go in and inspect the animations that are being used. So of course here we were using his selected actions, his idle and his walks, but I want to just go in and hide his rig so it doesn't show up. And I'll do the same thing for the female character, the Eliza character. Let's select her. Let's inspect her animations. Again, we can see these actions that are in use in CrowdFX, and again, we'll just hide her actor source model. At any time, we can remove actors from our crowd and add new ones back in. So one of the neat things about this is if we just hit play, you can already see that our crowd is essentially moving. And so that's as basic as CrowdFX is to get it started. Let's have a look at what's happened under the hood here. Go back under the CrowdFX simulation menu and let's inspect the crowd simulation tree. And what you'll notice now in the 4 branches, they now have been resolved. If we take a look at the animation sources core, we'll open that up and we can see that each actor has been brought in as a separate branch here, and each actor has loaded in each one of their actor cycles, each one of their cycles. So if I double click this one for example is my idle talking state. This one here is my walk state. This one here is my run. Actually, I should define these as action sources. These are not quite states yet. These are the actions that are loaded into the mixer. And the female character has the same thing. If we take a look at the emit and initialize branch, you can again see nothing's really changed here except that we now have actors have been loaded in. We're defining a number of actors here, say 20 or 30 or more. Defining the thickness of the actors so that they don't penetrate one another. We'll give them a bit of a larger thickness here. as well as their social group index and the random placement of the actors into the system. If I was to unplug this, you can see that it would just be taking, in this case, the male characters. And if I switch the actor ID to 1, it would just be taking in the female characters. But here what we've done is randomize the actor ID and randomly picked between the existing number of actors brought into our crowd effect system. If we have a look at the animation blending core, or at the animation blending, we'll go full screen on that. The animation definition is what's most important here. This is sort of managed on its own. Let's have a look at the animation definition. And this is the new area here where we are defining animation states. We're defining an idle states and defining our move states. So what we do, if we take a look at this, is we're choosing the name of the animation that we wish to reference. So in the case of the male character, we're using the actor, we're using the Eric model, and we're pulling in the idle action from that model, and we're defining it as our idle state. And of course that's meant to loop over and over and over again. We define a move state in much the same way, except the difference here is that we're able to pull in multiple references. So in this case, we're again using the Eric model. We've defined a state to hold all of our moving actions called move state. And of course, from slowest to fastest, we've got a walk cycle, 33 frames, and a run cycle. And the Eliza character has the same idle animation state that's been defined for her. There's her idle state. And of course, that's pulling in her talk on cell phone preset. And then we've got her move state as well, where we can see a transition from her walk cycle to her run cycle. Finally, all of these animations, or all of these states, get blended together using a state transition. The state transition defines a transition, a bidirectional transition in this case, from an idle state to a move state, and it blends them over the course of 5 frames. So if I'm in a move state, it'll transition to an idle state, and from an idle state to a move state. Now, the behavior core is what defines which state we currently are utilizing. If I take a look at the behavior core, you can see here that this is the default behavior core set up by the pedestrian setup. So we have the behavior core, and in it we're utilizing a basic crowd simulation that defines velocity. And we're defining the velocity using collision avoidance. So this is the collision avoidance aspect of the behavior core. And we're using, in this case, a goal sequencer to define where the characters move. Of course, we can set goals by walls here as well. The post-simulation branch is, again, taking into account any terrain that we might use and any obstacles and walls that the character might have to navigate. While the logic here to blend from state to state is very simple in its initial incarnation. Here we just have a set animation state node using a condition to determine which state is currently being used by the actors. So in this case, we are evaluating whether or not our actor's current target speed is greater than 0.1. If our speed is greater than 0.1, then we would naturally use a moving state. And then this animation state selector node, which is new for 2014, allows us to choose one of the states that we've defined in our animation blending tree. And if the actor's target speed is less than 0.1, then this defines a transition into an idle state. You can see here that we have a target speed set. Our target speed is set to 20. And so, of course, these characters are going to transition into a run, essentially, and they would never slow down. But this is where the logic gets kind of interesting. And you'll see in a couple of later examples, as I get a little bit more in depth into crowd effects, that this is a very powerful system that can pretty much do anything we can envision. So that's just a very quick introduction to the new branches to the animation and behavior ice trees and how they are implemented through the pedestrian crowd setup in Crowd Effects for Softimage 2014.